Hey, what's up, Web Mafias? Welcome back to the commute. And in this video, we are talking about interfaces in Kotlin. So let's get started. So here I have my Scratch file open. Let me quickly zoom in. Now, let's first of all look at the definition of interface. Interface in Kotlin can contain declarations of abstract methods and methods implementations. It means that interface in Kotlin are just like abstract classes. It just contains declarations of these abstract methods that can be implemented inside of other classes that want to use that interface, right? Or we can also provide implementations of the function inside of the interface. But what is the difference between an interface and abstract class? We'll look at that as well. But let's first of all make an interface and try to understand how it works in Kotlin. Okay, now interfaces are just like abstract class. They consist of methods or functions without functionality, but we can also implement these functions. Let's try to look at an example here. Now, interface, right? We have a vehicle here. Interface vehicle, right? A simple interface. There's a function, engine, right? As you can see, is no body of this thing, so I'll just remove the square brackets. And what do we have here? It's just an abstract function engine here. As you can see, abstract here. I'm not able to zoom in on this thing, but it's an abstract function here because it's inside of the interface, so anybody can implement this particular function, right? So let's make a class called class car, right? And we will implement the vehicle interface in this. As you can see, the red squiggly line appears over the car class. If we press Alt and enter and try to implement the members, and we have override engine. Now we have overridden the already written engine right here. As you can see, now we can just provide the implementation println cars engine, right? We can also make a class here, another class called bike because it's a type of vehicle as well, and we can just say println bikes engine. As you can see, it's working. So we have the same engine function written twice, and we have overridden, and different classes have different functionality. Let's try to make an object here. Bike is equal to bike, right? And you can say bike dot engine, and let's see what it does it give us. And if we zoom in, it's written as bikes engine. Okay, if we make our car of type of car object, right, and say car dot engine, it will just give us cars engine, I suppose. So we have cars engine here. As you can see, it's working properly, and that's what interfaces are doing, overriding the functions and implementing them in the classes that we want to. Why do we even use them? Why can't we use abstract classes instead of interfaces? Let's look at it with an example here. Let's first of all quickly remove all of this stuff. Let's suppose that there are two different classes, right? Two completely different classes, unrelated to each other, right? So they can't be using an abstract class because abstract class is a class. It is a blueprint of some kind, right? So there are two different classes with two different ultimate blueprints, and they are not related to each other, but there's a common property between these two, a simple common property, and we have to implement. We can't be writing two same functions again and again. Instead, what we can do is just use an interface. Two different properties of these classes, right? One common function of these classes can't use the abstract class. Class is a blueprint, so we use interfaces. As you can see, this is how interfaces are meant to be. Let's just take an example to understand it. Let's just say interface, right? Let's say maintenance. Let's suppose there is an interface called interface maintenance, right? And there's a function called function maintenance time period, right? Something like this. Now this is a simple interface. Now let's suppose there's a class called car which also requires maintenance, right? And we will have to implement this member, a println maintain 6 months, right? Every 6 months a car requires some kind of maintenance. Now there's a class called metro, completely different class of vehicle. It does not have any kind of same property. Engine is completely different, brakes are completely different, doesn't use a tire. It's a completely different class, but it requires some kind of maintenance. Or maybe let's take an example. Instead of metro, we can take example of or maybe AC. It requires maintenance, right? Air conditioning unit, it requires maintenance. It's a completely different class. class, but it requires a maintenance. So we have a maintenance time period here. Println every 1 year. It requires maintenance. I'm supposing, I don't know how much maintenance. I think so it's around 6-7 months. But yeah, AC requires some maintenance and car requires some maintenance. So these two classes are completely different to each other. A car is a vehicle, AC is used inside of homes, but they implement a simple interface, right? And they need to implement it. We cannot use an abstract class for it. We have to use some kind of interface. That's why interfaces are implemented. We can also use multiple interfaces if you want to. For example, car can also implement a vehicle interface, whereas AC can implement some kind of home unit interface. So multiple interfaces can be implemented. These are two separate classes with different properties. The car is a road vehicle, whereas AC is just a home unit, and both have maintenance periods. It means we use interfaces to define contracts or set of capabilities that can be added to the classes. If we look at the implementation of abstract classes represents a base class that other classes can inherit from. It acts as a common blueprint. For example, if we make an example of some kind of abstract class, let's take an example of abstract class as well to understand it more properly. Let's make an abstract class, class called animal. There's an animal inside everyone, right? Fun, make sound, and we have to, of course, say abstract in front of it. By default, interfaces have abstract functions, but in abstract class we have to specify that it is an abstract function. Say class dog, and of course we need to implement it like this, and then it will shout at us that please implement the members interface, println something, right? Dog is something, I don't know. Woof. Yeah, class bird animal. It's type of animal, right? Implement it, class, implement these things, and making sound, println, chirping, chirp voice. So these are abstract classes. They are animal, bird, and dogs are both animals. They have to have some properties common, and because abstract class itself is a blueprint, if you understand the difference between abstract classes and interface, and why do we use them? Let's try to understand the differences between abstract classes and interface and actually write them down. Okay, abstract class are supposed to be blueprints, whereas interfaces are not. They contain common functions that classes can implement, right? I hope this makes sense. Let's try to look at the difference of their functionality. Okay, let's just say interface vehicle. Now we have var tires of type of int. Now if you were to say that it has 4 tires, it will start to give us error. What is the error? Property initializers are not allowed in interfaces. It means we are not allowed to initialize properties inside of the interface. Okay, here it says convert property initializer to a getter. Let's convert it. What we have is tires int get 4, set value, some kind of value to do, value dot to string double something. Now if you were to get the backing field inside of it, does it allow us? The answer is no, it does not. Property of an interface cannot have a backing field. It means we are not allowed to initialize these tires here. It makes sense that the interfaces cannot store any data, whereas abstract classes can. I hope this makes sense. Okay, let's try to implement this. Let's try to override this. Override tires. We have a super type, set value something, right? And if you were to say car or car and say car dot tires, what will happen here is it will println 4, right? We are actually getting the value that is right here, but we cannot set it. So that's the difference between interface and abstract class. Abstract class, we can do all of the stuff a class can, but interfaces we cannot. So that's the difference between these two implementations. Interfaces cannot store values, but abstract class can. Interfaces are not common blueprints, but abstract classes are. I hope these two differences are pretty clear. Now, there's some important points to remember when we are implementing interfaces or abstract classes. The important point is that we can implement multiple interfaces, but not abstract classes. I hope it makes sense. Okay, let's try to implement different interfaces here. Interface, vehicle, fun, engine, interface, maintain. Now there's an interface called maintenance. We have a function called maintain time period. Simple two interfaces. We have a class car of making vehicle, comma maintenance. You try to implement both of these things. We can just say cars engine and maintain time period equal to 6 months. So these are two different interfaces being implemented inside of a car, and we can actually use them. Car.engine, car.maintenance time period, and we can see what will be the output. We have car engine, okay, in output, and maintenance time period is equal to 6 months. Hopefully it makes sense. Another important thing that we have to keep in mind is that if we implement an interface, then we are forced to implement all of its methods. It means that we have to keep in mind the solid principles interface segregation principle. It means that if you were to somehow say that let's suppose it's an example, it has tires, and let's suppose there's a class called airplane. We are implementing tires inside of an airplane, which is a vehicle, right? We are forced to implement these two tires, so we have to implement them even when we do not want to. So this is basically a violation of an interface segregation principle. So how can we solve this? Just implement here, and this problem is solved. We are not forced to implement it, and we can, if you want to override it, we can override it here. Override on tires, we can override it, and we can just implement super.type. Again, the scope of this thing is outside of this video, but of course interfaces are an important part of interface segregation principle, so we have to keep that in mind as well. There's another important point that in a case might come when we are implementing both same functions twice in a class, that we need to define how we are implementing them. For example, there's a interface, let's just say interface A, right? We have a function h. Interface B, we have a function h again. Let's say that if we say that class D implements B, comma A, if we try to implement these two functions have the same name, and we need to somehow override them. How can we do that? What we have to do is basically tell the class what function are we even using. Let's suppose that we have things inside of this h which is different from this h. Hello, right? This is a hi, this is a hello, and we are implementing h from both of these things. If we were to say this thing and we try to implement these members, we have two h's now. Now that's a problem, right? Now if you were to just remove one h and say that we want to have super of type of a dot h, it will implement the h. We want to have b, it will implement the b. Now we can just say something inside of it if you want to, hi and hello, and it will implement both of these functions, superclasses, without any problem. I hope it makes sense. It's highly unlikely that we'll be using this, but in case we are stuck with this kind of problem, what we can do is just use this thing. I've explained everything that you need to know inside of interfaces. The notes for this will be in the description down below, so I hope you guys really enjoyed it, and if you did, like, share, and subscribe, and I'll catch you next time. Bye bye.